Hello. Right, this is just a quick reminder for the November Reset class. It's an additional lesson here. So first of all, we're going to deal with significant figures, which is a type of rounding. We've done before rounding to decimal places. This is significant figures, and it means that every number after zeros, I don't know whether that's an E in there, after zeros are significant. Even another zero. So, what does this mean? Right, say we've got the number 342 and we want to round that to two significant figures. Every number after the zeros, there are no zeros here, so this is the first significant figure, the second and the third. So you take the second, because that's what we're after, you go to the right and you don't round up, you just round down, yeah, to 342. So there are no problems with the zeros at the beginning. Okay, so let's have a look at 4205. Okay, let's do this to three significant figures. So remember, this is the first, this is the second. Now this zero, because it's sandwiched in between all the rest of it, is actually a significant figure, and that is 4. So this is the third significant figure. So let's look at that 5 and we go up to there. And don't forget, make the number the same size. So that's when you have a 0 in the middle, you count it as a significant figure. And this, the point about the zeros at the beginning, really comes into its own if we've got decimal numbers. So let's do this to two significant figures. Right, so these are not significant figures because they're zeros at the beginning. This is the first, this is the second, and this is the third. So we're going to do two significant figures. This one, go to the right, it's 8. So you round up to 5. And there's no need to put a 0 at the end because it's after a decimal point, so you don't need to. And the other one might be 0.03207. And we're going to round that to three significant figures. So no, yeah, 1, 2, 3, and 4. So this is the third significant figure. Look at the 7, that goes back up to 1. There, rounding to significant figures. Next thing we looked at was estimate. Now estimate is when you round before you calculate. So we don't round at the end, we round at the beginning, and you will always see this in the exam question. So say if we have 42.6 times 12.1 and we'll divide that all by 7.9, we've got to round these numbers to make it as easy as possible. No, so we could do 40 times, I don't know, 12 divided by 8. The key is you're looking for a number at the bottom that will divide into the number you end up with at the top. So that will be 480 divided by 8, which will be equal to 60. Now, some would argue, and I would be all right, that you might want to do 40 times 10 over 8, which will then be 400 over 8, which will then be 50. Either is okay. Either is okay. It just depends who sets the question and what they're looking at. But both ways, you are able to divide by 8 without any hassle and without any leftover. Next thing we looked at in some detail were powers. Now these are little numbers that we get there, the power numbers, the little numbers at the end. Now that means 3 times 3, which is 9. And most of the power questions that you get will involve algebra. And first of all, we've got to multiply power numbers together. So if we did a number, we do 3 squared times 3 to the 4. Now, as long as these two things are the same, you can go ahead. And what you do when you multiply, you add the powers. So this will be 3 to the 6. Yep. So we just add these little two numbers at the top together, and as long as they're the same, you're fine. It's because we use this in algebra, and you might get d squared times d to the 4. And see, both d's, so you would end up with d to the 6. It would be exactly the same thing, except you don't know the value of d. Right, so if you, when you multiply, you add the powers. When you subtract, or when you divide, so we do letters, yeah? A to the 9 divided by A to the 4. So when you divide, you subtract the powers. So 9 take away 4 would be equal to A to the 5. That's fine. Right. Another little rule of powers is what happens if you get a negative number. So say you've got 4 to the minus 2. What you do here is you use the reciprocal. Now the reciprocal just means 1 over, turn it upside down. So for example, 4, the reciprocal of 4 is 1 over 4. 99 is 1 over 99. That's all you do. You're putting 1 over, and see that you can go the other way. 1 over something, the reciprocal is just a regular number, because it would be 99 over 1, but we wouldn't need that, would we? We'd just call it 99. So we're going to write 1 over 4. Now when you do the reciprocal, the minus disappears, so you get 4 squared. And 4 squared is 16, so in this case we can go 1 over 16. Fine. So just 1 over. So 5 to the minus 3 will be equal to 1 over 5 to the 3, which is cubed, which equals 1 over 5 times 5 times 5 is 125. So if you're using algebra and you've got x to the minus 4, that would equal 1 over x to the 4, and you cannot go any further unless you know what x is. There's another one, raised by another power. You multiply. Alright, so what does that mean? So if you have x to the 2 and it's raised by another power, say 3, then you multiply the 2 and 3 together. So that would come out as x to the 6. If you have 2 squared, that would equal 2 to the, multiply them, don't add them, multiply them, 2 to the 4. It comes out the same number. 2 to the 4 is 2 times 2 times 2 times 2, which is 2, 2 is 4, times 2 is 8, times 2 is 16. So that equals 16. Raised by another power. Right, what else did we do? No, did some other things. Powers. Minuses. That will be okay. Now, then we looked at, whoops, standard form. Flying through this stuff today. Standard form, okay. So standard form is where the first number is between 1 and 10. And this is a way of writing very large or very small numbers. So let's look at what a standard form number looks like. So we could have 4 times 10 to the 3. Now this means the 10 to the 3 is 10 cubed, which is 10 times 10 times 10. So 10 times 10 times 10, it would sort of could be 4 times 10 times 10 times 10. Yeah, which is 440, 400, 4,000, 4,000. Now, if you have 4 times 10 to the 20, this would be 4 times 10 times 10 times 10 times 10, 20 times. So it's a really easy way of looking at a very large number, or in fact a very small number, which we'll get onto in a minute. And we need to be able to convert between standard form and ordinary numbers, and also the other way around. So let's do some conversions first. So 3 times 10 to the 3. Now that's a standard form. Now as an ordinary number, an ON ordinary number, we would put the 3, and then we put the number, we put zeros, but we'd put 3 lots of zeros. 1, 2, 3. Because that number is 3, we're going to put 3 extra places, extra place markers at the end. So 3 times 10 times 10 times 10 is 3,000. So 8 times 10 to the 2 would be 8 and 2 zeros on the end. Now, we said that this standard form can be any number between 1 and 10. So we could have a decimal times 10 to the 4. Now this time, I'm going to use a little trick here. I'm going to write my 4.2. Yeah, this is rough working out. And what I'm going to do is I need to move 4 places. So as there, I move the number 2 places to the left. Here I move the number 3 places to the left. So I need to use this 4.2 4 places to the left. So I'm going to start here and go 1, 2, 3, 4. And then I'm going to fill that up with zeros, because that's where the decimal point ends up. So that would be 42,000. Let's do another one like that. 6.72 times 10 to the 5. So I'm going to write my 6.72 there, and then I'm going to move my decimal places 5 to the right. 1, 2, 3, 4, 5 there, and fill that in with zeros. Therefore my answer is 672,000. What about going the other way? Going the other way. So going the other way, we'll have a standard ordinary number there and a standard form. So ordinary number 342. Yeah, standard form, it's going to be 342. Yeah, so what I do here is I count from where my decimal point is going to be to the end. So I'm going to go 1, 2, 1, 2. So I've moved my decimal point twice there. So this becomes 3.42 times 10 to the 1, 2. Yeah, times 10 would be 34.2, times 100 would be 342. So you go from where your decimal is going to be, yeah, and go to the end of the number. Let's do that again. So let's go 491000. Okay, so it's going to be 4.91. Got that. Then it's going to be times 10. Now we've got to work out how many it's going to be for the power number. So go from 4.9, go 1, 2, 3, 4, 5 to the power of 5. Can we do an ordinary number as a decimal number? Well, we could do, I don't know, let's say 4.2. That's the easiest one. It's going to be 4.2 times 10 to the 1. 10 to the 1. Right, so that's all big numbers. So let's do some small numbers. So we'll start with 0.004. Yeah. So as standard form, this is going to be 4 times 10 to the something. Now, from the decimal point, or you can start from the end of the number because it's there, isn't it? The decimal's just after the 4. You can go 1, 2, 3 till you get back to that decimal point. So it's 3. But it can't be that because that would be 4,000. So it's minus 3 because we're going this way that time. It's less than 1. So it's got to be a minus. 0.026. So we're going to put 2.6 times 10. Now we go from the 2.6 and we go 1, 2, minus 2. 0.00087. 8.7 times 10. From the 8.7, 1, 2, 3, 4, minus 4. Okay. The other way, 3.6 times 10 to the minus 4. Okay, so what are we doing with this? Right, so what we need now is we need to go from our decimal point and we need to go the left direction. 1, 2, 3, 4, so that the point would end up there. Fill in all the gaps with zeros, so it would be 0.00036. Yeah, whether you put that first 0 in there before the point, it's up to you. It makes it clearer. Okay, so 7.14 times 10 to the minus 8. Okay, so go from the 7.1 and we're going to go 8. So 1, 2, 3, 4, 5, 6, 7, 8 there. Fill in all the zeros and we've got 4, 5, 6, 7 of them. So that would be 1, 2, 3, 4, 5, 6, 7. I'll put a 0 point there. And then my number 714. Yeah, so that's how to go backwards and forwards, this way, that way, with standard form. Now, we've got to multiply and divide with standard form as well. So let's have a look at 3 times 10 to the 2 times 2 times 10 to the 4. So you do the separate bits. You do these bits and you do those as well. So 3 times 2 is 6. And 10 to the 2 times 10 to the 4, remember we add them, it's just 10 to the 6. Now, you can get caught out. So if you got 4 times 10 to the 4 times 3 times 10 to the 2, you go 4 times 3 is 12, and then 10 to the 4 and 10 to the 2 makes 10 to the 6 because we're adding. But this number here is not in standard form because it's not between 1 and 10. So you make it smaller. and 1.2. You divide by 10. So to balance it out, you've got to make this one bigger, multiply by 10, which will then be 10 to the 7. That's fine. I suppose you can divide by saying 8 times 10 to the 4 divided by, you'd have to choose your numbers very carefully here, 10 to the 2. Yeah, so 8 divided by 2 is 4. 10 to the 4 divided by 10 to the 2 is 4, take away 2 is 10 to the 2. It can be very messy if these don't, you know, you can't have a 10, you can't have a bigger number over there than what it is on the left, otherwise you wouldn't be able to divide. But you might get a division where this doesn't go in very nicely. Yeah. But they've got to be between 1 and 10, so it's not going to be far off. So add. So let's do 8 times 10 to the 3 plus 8 times 10 to the 3. Right, this is okay, isn't it? Yeah. Now, if these are the same, we're okay. So I'll put there must be the same. So once they are the same, you can just add them together. So 8 times 10 to the 3 and 8 times 10 to the 3 is 16 times 10 to the 3, which is not in standard form. So make that smaller, 1.6, make that bigger, 10 to the 4. Yeah. Now what if they're not the same? Okay, what if they're not the same? 7 times 10 to the 5, add 8 times 10 to the 6. Right, remember that these have got to be the same in order to add. Right, so, but they're not the same, are they? So let's make them the same. Let's make that 10 times bigger and call it 10 to the 6. So then I make this 10 times smaller, 0.7. Don't worry about it not being in standard form. We're only using this to add the things together. We'll put it into standard form in a minute. So 8 plus 0.7 is 8.7 times 10 to the 6, because we're adding, yeah? And this way, if you go for the smaller number, your answer is always in standard form. Subtraction, exactly the same, but the other way around. Then we looked at error bounds. Now this is a tolerance on something. So say we measure a room, and the room is 9 meters long, but to the nearest 1 meter. Now there's the clue. You will always find that word in the question so that you know it is an error bounds question. So this is the tolerance. So you have a tolerance of 1 meter, and what this means is there is our 9 meters that we expect the room to be, but it could be a bit shorter and it could be a bit longer. Not by a meter, half the tolerance. Half the tolerance. So it's half a meter or 0.5 of a meter. Always half of what this is, because then this can be 8.5, the smallest, and this would be 9.5, the longest. And you'll see that the difference between here and here is our 1 meter tolerance. So you go half up and half down. So imagine now we baked a cake, and the cake is 2.5 kilos to the nearest, the nearest 10 grams. Now, so remember half of this, so you can go 5 grams up or 5 grams down, and 5 grams up, 5 grams down. So this is 2,500 grams plus the 5. So this would be 2,505 grams is the largest it could be, or take away 5 would be 2,495 grams, the smallest or the lightest it could be. Okay, that's that. I'll see you in the next one.